Today, we're pulling back the curtain on the fundamental grammar of Python. We're going to break it all down piece by piece so you can really understand the language that powers so much of our digital world. Let's jump right in.
You know, that's really the best way to think about Python. It's not just a bunch of cryptic symbols on a screen. It's a full-on language. It has its own alphabet, its own words, and most importantly, its own grammar. And by the end of this, you'll get the core rules that make it all click.
So what makes Python so popular, especially for beginners? Well, its syntax, the way it's written, is designed to be super clean and simple. A lot of the time, it actually reads a bit like plain English, which is a huge reason why it's such a favorite starting point.
Okay, so how do we actually speak this language? Well, there are two main ways to communicate with Python, and they each have a different purpose. Think of it like this. You can have a quick, casual chat, or you can sit down and write a long, thought-out letter.
This slide really lays it out. On one side, you've got interactive mode with that triple arrow prompt. It's like a conversation. You type a command, you hit enter, and bam, you get a response right away. It's perfect for testing little ideas. Then you have script mode. This is for building something real. You write all your commands in a single file, a .py file, and then you run the whole thing at once. This is how you build actual applications.
All right, let's get into the real grammar. See, just like our sentences are made up of words and punctuation, every single Python program is built from smaller, meaningful parts. And these little parts are called tokens.
A token is the absolute smallest meaningful piece of your code. Think of it as the atomic unit, the single Lego brick of your program. It could be a word, a number, a symbol. If it has a specific meaning to Python, you can bet it's a token.
And these tokens all fall into 5 main buckets. You've got keywords. Those are the special reserved words that Python keeps for itself. Then there are identifiers, which are the names you create. Literals are just fixed values, like a number or some text. Operators do the work, like adding things together, and punctuators give your code structure.
For now, let's just zoom in on one of the most important types, one you'll use constantly: identifiers. You can think of these as the nouns in our Python sentences. They're the custom names we give to our data to keep everything organized and make sense of it all.
But it's not a free-for-all. You can't just name them anything you want. There are a few simple rules to the game. First, your name has to start with a letter or an underscore. After that first character, you can use letters, numbers, or more underscores. And this is a big one. You can't use one of those special reserved keywords. Oh, and always remember, Python is case-sensitive, so age with the lowercase a is a totally different thing than age with a capital A.
And you can see those rules in action right here. Student 1, totally fine, but first name is no good because it starts with a number, my name won't work because of that space, and 4 is a definite no-go because it's a keyword Python needs for its own use.
So, we have these names, these identifiers. What's the point? Well, we use them as variables, which are basically containers to store information. And the main tool we use for this is the assignment operator, that simple little equal sign. The structure for this is always the same. Variable name equals data. Think of the variable name on the left, the L value, as the label you slap on a storage box. The data on the right, the R value, is whatever you're putting inside that box. The key thing to remember is the name of the storage location always goes on the left.
So let's look at what's really happening under the hood. When Python sees a line like price equals $599.50, it first looks at the thing on the right, the value, $599.50. Then it finds an empty spot in memory and gives it the name from the left, price. And finally, it tucks that value away in that newly labeled spot.
Okay, so we know how to name our storage boxes and how to put things inside them. The next logical question is, what kinds of things can we actually store? This is where data types come into play. Python needs to know if it's handling a number, some text, or maybe a whole collection of items.
To make this all feel a bit more real, let's follow a quick case study. Meet Mira. She's building a simple app to manage books in a library. To do that, she's going to need to store different kinds of information, and this is going to show us the core data types perfectly.
First up, Mira needs to store how many pages a book has. Let's say it's 450. Since that's a whole number with no decimals, its data type is an integer, or just int for short.
What about the book's title? Well, that's just a sequence of text characters. In the world of Python, we call this a string, or str. The easiest way to spot a string is that it's always wrapped up in quotation marks.
Now, Mira wants to start collecting student reviews, but she doesn't have any yet.
For this, she can use a list, which you create with square brackets. Lists are amazing because they are changeable or mutable. This means she can add new reviews, remove old ones, or change their order whenever she wants. Perfect for data that's always changing.
Now, what about the author's names? Those are pretty fixed. They're not going to change. For something like this, she'd use a tuple, which you create with parentheses. A tuple is also an ordered collection, just like a list, but here's the key difference. It's unchangeable. Once it's made, it's set in stone.
Another super powerful data type is the dictionary, or dict. This is great for storing related pieces of information together, kind of like a digital contact card. You have a key, like the word name, and then you have its value, like John. It's a fantastic way to keep related data bundled up. We just saw the difference between changeable lists and unchangeable tuples. You know, this concept is so fundamental to how Python works that it has its own special name, mutability. Let's make sure we've got this down. So this slide lays it all out. On the left, you have mutable types, like lists and dictionaries. You can modify them right where they are. Add an item, and it's still the very same list. But on the right, you have immutable types, like tuples, strings, and integers. If you try to change one of them, what Python actually does is create a brand new object in memory. Understanding this difference is absolutely key to writing good, efficient code.
So, to put it simply, if you have a tuple that looks like 1, 2, 3, there is just no way, no how, that you can reach in and change that 2 into a 5. The data is locked in. This is why choosing the right data type from the start is so important. You use mutable types for things that need to evolve, and you use immutable types for data that you need to protect and keep constant.
And there you have it. We've covered the alphabet, the words, and the core grammar of Python. You now have the fundamental building blocks you need to start writing your own code. You can form your own sentences and start telling the computer exactly what you want it to do. So the only question left is, what's the first thing you're going to create?